Friends, today I am going to talk about dielectric constant or relative permittivity. Whenever we talk about electrostatics, we come across a word called permittivity of free space or permittivity of the medium. In today's video, I am going to talk about how permittivity of free space and permittivity of medium are related to each other and how to define dielectric constant or the relative permittivity. For that, let us revise the Coulomb's law. So let us revise the Coulomb's law here. The Coulomb's law telling force of attraction or repulsion between 2 point charges. So let us say this is the first point charge Q1 and this is the second point charge Q2 and the distance between them equals to R. So the force of attraction or repulsion between 2 point charges at rest is directly proportional to product of magnitude of charge. What is Q1? Q1 nothing but magnitude of first charge, and what is the Q2? Q2 is the magnitude of the second charge. So F is proportional to product of charges, that is Q1 into Q2, and inversely proportional to the square of distance between them, that is F is proportional to 1 upon R square. So we got here the two equations 1 and 2. Now joining both of them, so F is equals to K into Q1 Q2 upon R square. What is K? K is the constant of proportionality. K value depends upon where we keep the charges. If you are keeping the charges in a medium, this is a medium, or you are keeping the charges, if you are keeping the charges in vacuum, so the K value is different for medium and the vacuum. If you are keeping in the medium, then the K equals to 1 upon 4 pi epsilon, and if you are keeping in the vacuum, then K equals to 1 upon 4 pi epsilon naught. Epsilon naught is called permittivity of free space or vacuum, where epsilon is called permittivity of the given medium. Thus K value depends upon where you are keeping the charges. If you are keeping the charges in medium or in vacuum, depending upon that we can decide the value of K. What is permittivity? Permittivity is nothing but ability of a material to oppose formation of electric field. Okay. Another meaning is that ability of a material to oppose flow of field lines. So how much opposition? That can be measured with the help of permittivity of the material. Similarly, when it is a vacuum, so we utilize the symbol epsilon naught. So epsilon naught will tell ability of vacuum. In place of material, what will be written over there? Ability of vacuum to oppose the formation of electric field. Or we can also say ability of, instead of material, what will come over there? Vacuum will come. So ability of vacuum to oppose the flow of field lines. So permittivity, there are the two. What are the two? One is the epsilon, another is the epsilon naught. Epsilon for material medium and epsilon naught for vacuum. Now we first keep the charges in vacuum. After that, we keep the same charges in material medium. Here, the two charges kept in the vacuum, they are the Q1 and Q2. Distance between them equals to R. And here in material medium, the two charges Q1 same charges, and the distance between them as well as the same, that is R. Here let us say force F1. Here let us say force F2. Here F1 is nothing but 1 upon 4 pi epsilon naught, because permittivity of free space or vacuum is equals to epsilon naught. So 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Call it equation 1. And here F2 equals to 1 upon 4 pi. Epsilon naught will not come here. Only epsilon will come. That is the permittivity of material medium. So 1 upon 4 pi epsilon Q1 Q2 upon R square. Call it equation number 2. Now dividing first equation by second equation, that is F1 upon F2 equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square divided by 1 upon 4 pi epsilon Q1 Q2 upon R square. After that, whatever the things getting cancelled, cancel them, like 4 pi gone, Q1 Q2 gone, R square and R square gone. What is left now? F1 upon F2 equals to 1 upon epsilon naught divided by 1 upon epsilon, implies F1 upon F2 equals to epsilon upon epsilon naught, where the ratio epsilon upon epsilon naught is nothing but epsilon r. So epsilon upon epsilon naught, this is nothing but called dielectric constant of the medium. Of the material medium. It is also called relative permittivity. Relative permittivity of given medium. Now, what is the importance of dielectric constant? There are many uses. You can talk about the importance of dielectric constant. The first use, to decide type of material to be utilized in design of capacitors. What are capacitors? That we are going to discuss in coming videos. After a few videos, I shall be talking about capacitors. So in design of capacitors, the concept of dielectric constant is utilized. Dielectric constant also help us to decide amount of electrical energy that can be stored between the plates of capacitor. Third one, in design of fiber optics, and in heating a material by using electromagnetic energy. There also you are utilizing the concept of dielectric and dielectric constant. And one more use, to decide degree or level of polarization. So these are the few uses. The more uses also are there, but I have given you some few important uses of dielectric constant. So today we have understood what exactly the dielectric constant. So I hope you got through the concept. Meet you again with next topic. Till then, wish you good luck, all the best.